Welcome to Ferment Radio, a podcast series that takes you deep into the fascinating world of microbes. My name is Aga Pokrywka, and I invite you to join us in a conversation with people from the most diverse backgrounds, including science, gastronomy, and arts, to develop new recipes for living on a broken planet. 200 years ago, the very first illustration of prehistoric times in a scientific context was brought to light. It was painted by British geologist and paleontologist Henry De la Beche, who was inspired by fossils collected by Mary Anning. The artwork known as Duria Antiquior, the more ancient Dorset, cuts through coastal waters to depict the epic and strangely simultaneous battles between different marine species. We can see a large ichthyosaur biting the long neck of plesiosaur, while another plesiosaur is about to surprise a crocodile on the shore. Furthermore, there is yet another plesiosaur stretching out to catch a pterosaur flying above the water. But hey, wait a minute. Did these species ever meet? Why are they so violent? How come there are no depictions of cyanobacteria dominating the planet 3 billion years ago? Maybe this representation tells us more about humans than about prehistoric animals. Welcome to a brand new episode of Ferment Radio, full of stories to be retold, deep time, cyanobacteria, and the inevitable fate that awaits all species, extinction. We are guided by Björn Kröger's expertise in marine paleoecology, paleobiology, and his interest in the history and philosophy of earth sciences. Björn is also the curator of the Paleontological Collections at the Finnish Museum of Natural History in Helsinki and the docent at the University of Helsinki. Let's take a trip in time.
This is kind of a famous picture. It is the first of something like a popular depiction of how people or scientists in that time imagined how, like, the deep time. But it is from the mid-19th century, and by that time people realized that there was like a deep past with lots of organisms, large and very interesting ones, that don't live anymore. So that people realized there is a deep time of deep history of life, and they tried to, usually they wrote about it, but this was the first time that someone really tried to draw a cartoon of it. And it was really, and this picture then was used to popularize like paleontology. It was not named by that during that time, but so it came into the hands of a German geologist, I think really early in the 1830s already. And he gave a few talks in Germany, and he was really famous by then, like Leopold von Humboldt, Alexander von Humboldt. And he gave, and some of these talks, the autographs, the scripts of his talks are archived in archives, and I found one of those and transliterated it, and it tells a really fascinating story how people by then tried to make sense out of the fossils and tell a story. And this is kind of a story of the history of life that is still told today in a sense.
This is exactly what I wanted to ask you, because when I browsed through your paper, and I also saw that at the end you have a transcript of actual thing, and then there is this image, which looks basically very contemporary, meaning that I don't think there is so much visually different in depicting like old times, some dinosaurs, whatever, like these creatures we know from Jurassic Park, basically, that it didn't change. And it shocked me because it was 1830, so it was like 200 years ago. And the science in many different fields, like actually we know about bacteria now, or we know so much about, I don't know, astronomy. But it surprised me that visually this interpretation of fossil fuels didn't change for 200
years.
It is
in the popular image. And this is like, it's really shocking or really fascinating that we have a picture of how it's so trivial and it like it's basically a story of survival of fight for survival and of tragic drama of the eaten and to be eaten and things like that. So we can tell a different story and we could visualize this in different ways, and it's probably like it's the easiest way to. Even today, the natural history museums, they're totally catched in this story. So they always have these big dinosaurs in the middle, and they are walking in one direction, like a big march or something like that. So the iconography of modern museums today is still the same because it works. It gives attention. I think the kids like it. and because the kids like it, the adults, they remember then always when people walk in the Natural History Museum, they say, yeah, I love it since my childhood. I need this. This is this dinosaur I know already from my childhood and things like that. So it is like, it forms like a universe by itself, which is very stable, it seems like. So there is not much change. And there is, I mean, I can talk a lot about this, but there's a wonderful early paper by Donna Haraway about this from, I think it was maybe even one of her, like close to their dissertation or so, I don't know what, long paper about the American Museum of Natural History in New York, the displays they have of their story, of their displays, their dioramas from Congo and from Africa, which basically also tells always a very similar story, that you have these big predators and big lions and pumas and not from South America, but in this case it talks about the story of the gorillas and the hunting of the gorillas by some.
Do you think it could be so that this image is all wrong and is just being repeated?
Wrong, like all images that we have from that time, because we cannot make an image because we don't know. An image is always an abstraction of a process. So if you make a photograph, you could think it's like a snapshot in time or something like that. But in these images, there is something often, it is like a high abstraction. So they are very diagrammatic. They bring animals together, which first, we don't know exactly how they looked like. Second, they didn't live together in one place. The other thing is that it's a marine environment. And in a marine environment, we all have not, very few of us have ever have been deep underwater and looked underwater with how this looked like there. So it needs also a visualization of this deep underwater worlds. And this is also something, but I never wrote about it or anything like that, but I came across it, that there's also a visual story about the aquarium. So at some point, people started to have aquariums in their homes. And that created a certain image of how you look at water from, you have this view behind the glass from the side. So, and this is also, this picture, this Duria Antiquior is basically an aquarium. You look like into an aquarium or in a terrarium or so. So that was probably, even in that sense, kind of a novelty, how the artist used this picture for, or the ideas how to visualize these strange worlds. Yeah. So it's highly diagrammatic, and it to tell a different story today, it really depends who you would address with these pictures. And I think in a museum, natural history museum environment, the people always are dependent on attraction. So there will be always this drive toward the predator and toward the drama. So it's really difficult, like, to show, for instance, microbial worlds.
There was this big event in Earth history when cyanobacteria dominated all oceans, right? And they started to do the big production of oxygen and killing everything else around. How this image could look?
It might be very simple, because we see it at the moment in many places, in places where we have where there is overnutrition in lakes or oceans. There are lots of cyanobacteria which produce oxygen, which is good, and it looks beautifully green in a sense. Of course, it's a poisonous green. And so it would be a green ocean. And below that green surface, there's fouling dead matter, very smelly. So it would be probably kind of beautiful in a way. Yeah? So during that time, I think it is, if I remember right, something like 3,000 million years ago or something like that, or even more, the Earth rotated faster and the moon rotated faster, and it was much colder also, the sun or something like that. Yeah, the sun is getting hotter. So everything was different. Maybe the light was also different because ozone layer didn't exist maybe that strong, or maybe there was even a different type of light, but I don't know. That's complete speculation. I don't know that. To show it, maybe it would be even interesting to it's more like smelly, yeah? to have it like a smelly landscape or something like that. I don't know, because of course the oxygen levels were not that high as today, so it was like at some point it reached a threshold or tipping point, if you so will. There was so much oxygen in the oceans that, at least in the shallower oceans, the oxygen level was so high that all the minerals, the water was had a reducing environment before. The solution in the ocean, if you imagine a water without oxygen, contains a lot of soluted iron and metals and things like that. And when it becomes oxygenated, these things oxygenate and form this iron oxide, is Rost in German. It's rusty. And that formed worldwide huge, massive deposits of iron oxides worldwide in many places. And where it is preserved today or close to the surface, it is mined still. So like, for instance, in Curator, that's this iron that's from that age. Basically, it was a tipping point in Earth, but to imagine or to make a picture of that would also involve somehow you have to make a choice. Do I want to show the ocean, or do I want to show some kind of deeper water or lighter water? Where I put myself in that world. These images are produced for certain reason, but they shape our way how we think about the deep past very much. So it's a little bit tragic.
This landscape dominated by cyanobacteria wouldn't be so different than the blue-green algae bloom. But are these organisms, so there's blue-green algae, which are coming in many lakes and seas around the world, are these very similar organisms as this very, very ancient cyanobacteria?
Of course, they also changed, but I think the way what they do and the way how they reproduce and how they, of course, we don't have like physical evidence, fossils direct of such a singular cell. There are a few chains of cells of these filamentous blue-green algae, which look very similar. So even maybe the physical appearance didn't change much in all these billions of years. And at least what the molecular evidence tells, there is not much change. If nothing really dramatic happens, they will be around also for a long time. Cyanobacteria need light and carbon dioxide, and from that they produce sugar. but they also need lots of nutrients like phosphor and nitrat and things like that. And this is something which is often more rare than light or anything like this. And this limits today the places where you don't have these algae. There are few nutrients. This is one thing. And the other thing, there are other organisms who eat them if they are not too poisonous. But there are groups of cyanobacteria who are able to, in case they need it, to get their nutrients out of the air, also nitrogen they can use, and it's such an abundance, so that's always there. That will be always there. So cyanobacteria will always somehow, they will manage. If everything else is gone, the cyanobacteria, they will, or the bacteria, they will survive, or they will thrive on.
So, for example, spirulina, which is quite common as like a superfood, is also a very similar species. And they also, like, natively, they live also in the lakes. Actually, just a few weeks ago, I came back from Mexico, and Mexico City is built on top of the lake, and in the remains of the lake, there is still spirulina, and some people even harvest it to eat it, because it was like a pre-Hispanic diet.
In our times, the greenness is also a sign of devastation, at least in the lakes and in the Baltic Sea and so on. But it's always the perspective. So if you look in the history of life, there is this time when cyanobacteria produced oxygen, but there is the other time when cyanobacteria got included into other organisms as symbionts. There is also, so they play a role in all higher plants, in corals. So there is a whole variety of this related organisms, protists who do photosynthesis. When they produce oxygen in their microenvironment, on the membrane of their cell, some of the cyanobacteria, they grow as microbial mats on the surface of some sediments and so in the water. And this microenvironment, that gets changed a little bit. So there is more oxygen, more volcanic environment. What it makes is that calcite, which is also in the sea, it forms a composition with carbon dioxide, and that means it will be then calcium carbonate. And calcium carbonate is limestone, chalk. And this is massive, what these cyanobacteria produce. And one can say all limestone which exists on Earth today is produced by organisms, and the majority of it exists only because there are photosynthetic organisms. And so all our concrete, the buildings where we are sitting in and everything, this is all exists only because cyanobacteria or photosynthetic organisms produce skeletons from forming calcium carbonate, and we are using the buildings and we are using all this. And this has also a climate impact because it binds carbon dioxide. And I don't know how much carbon dioxide, I don't know the math behind, but it must be massive how much carbon dioxide is in this rock bound and taken out of the atmosphere to cool it, basically.
So are cyanobacteria the oldest living organism?
That's a question of the beginning of life. Then microbes, so bacteria are among the oldest. And there are other microbes which are also, like the archaeans, which are also very old. And I don't know the actual history of the latest literature, because it's a very dynamic field. But at the moment, I think the oldest evidence of cellular life which is like uses or is also in cells, like we know it in microbes. This happened in cells which do, I think, not photosynthesis, but synthesis of sulfur and things like that. And that was probably closer to some hot volcanic undersea environments, which were very stable over millions of years and so on. So this was probably an environment where life evolved early on Earth. Cyanobacteria have used photosynthesis, and photosynthesis only appeared like, I don't know, the millions of years ago, but relatively late, 2008 million years ago. I can Google it. I usually don't have the million years in my head, but so the first animals came roughly 600 to 500 million years ago. So 540 is the beginning of the Cambrian explosion. Then we had the first multicellular organisms which were able to walk around, to crawl around and to eat others, and like more complex multicellular organisms. And and humans evolved like 6 million years ago. So this is the time behind. Yeah,
I know you've been also researching on on change, basically, like how different systems emerge and how they decline. Would you have any idea in which place of their curve of rise and decline cyanobacteria is?
They are part of a system. Life is something that we can only understand as a process of different actors or acting entities, kind of stable but evolving entities. So you have to look at this system when you ask for in which part of the rising. So the reference here is that I'm part of a research group where we think about the evolution of systems in a way which is also a narrative which appeared at some point also in the 19th century or 18th century, actually, with Goethe and Herder and so on, and Germans, that there is a system, or let's say, for instance, a civilization which starts at one point, grows, has a climax, and then it goes down, and then it's the end. So there is this, like the Roman Empire usually is the first way to think about it, that there is this the rise of the Roman Empire and then the end of or organisms. We think the same. It is an organism. We are born, we thrive, and everything is nice, and then we get age, and then at some point we die, and then it's the end. And you can think of it as a curve or as a rising.
If you liked this episode, please share it. If you would like to know more about the show, listen to this episode again, or find previous episodes, please go to fermentradio.com. You can subscribe to this podcast on Spotify, Apple Podcasts, and more.
Maybe only two.
We would love to know what you thought of this conversation, hear your human microbial stories, and your suggestions for the future episodes.
And then
we are always looking forward to hearing from you at hello@fermentradio.com. You can also leave us an audio message by connecting to us on our Instagram.
Everywhere in the world,
Ferment Radio is brought to you by Super Eclectic and is supported by Microbial Lives, practices of new human microbial cultures, a project at the center of the social study of microbes. I'm very grateful for this support, and most of all, with all our amazing Ferment Radio listeners.
It just goes on explosively.
And stay tuned for the next episode of Ferment Radio.
But it will not go on forever explosively, because always it goes down at some point.
So the curve is really long, basically.
And they will certainly, by definition, they will go extinct definitively at some point, because the sun is getting hotter and hotter and hotter. And if I have the right time, the numbers right, it will be roughly in 600 million years that the Earth is too hot for anything. So at least 600 million years in the future.
And there is so much being spoken these days about the extinction of different species. I wonder, do you have any knowledge how does it relate to bacteria as a group? I know this is very big because they are everywhere.
Ecologists and biologists and so often look at, when in terms of evolution, evolution of ecosystems, they look at macroorganisms. So what we have in mind are, or at least like multicellular, or like these kind of organisms, how they evolve and so on and thrive. And now it becomes more and more clear that you cannot look at this evolution of, for instance, trees or plants isolated from their microbiome. Same for us. So without our microbiome, we wouldn't be able to survive. It could be like the dinosaurs, for instance, had a certain microbial ecosystem which doesn't exist anymore because it went extinct with the dinosaurs, or the dinosaurs went extinct with this microbial, but we don't know yet.
So basically when the species gets extinct, then some certain, like a microbial ecology, extincts together with that species in a way.
And it might be only our focus that we think this species goes extinct in the other way. Maybe we could also talk about that this system goes extinct. And that's an interesting way about looking at extinction, not looking at disappearance of a species, but as a species at the disappearance of a certain way doing things in a community, or in an ecological community, or of a certain community that disappears. So because if a species disappears, that is never a single event. It's always there is something else missing. Then it has always like a small or a big chain effect to some other species. People usually count species, and then they count how many go extinct and how many new appear and so on, but not what they are doing, and to quantify that and to understand that, and it would be interesting. And the bacteria, to come back to the bacteria, they are usually overlooked in this play. There are, I think, at least as a paleontologist, because there is no paleontology, very little paleontological traces, bacteria.
If I could take us a little bit back, because we mentioned this term deep time several times, and I realized that we never kind of explained what is that. Could you tell in few words what is deep time? And something I'm really curious, when did it start? Because time usually starts at some point, right? When did they start to talk? But also, like, how do you measure it? Because even like when we say like, oh, this species appeared like this million years ago, or in billions, then there has to be a zero somewhere, right? And what is the zero?
Zero is now.
Ah, yeah, of course. Okay, so it can keep extending.
Forever, yeah. But usually the beginning is 10 10,000 million years ago, when the universe. But before the universe, there was also something. So it can go forever, basically back.
So basically, deep time, it's like the history of everything.
Everything deeper, like history. There is this historical division between the prehistory and the history. And the history is the time which is the time when people started to write something. And this is, of course, a deeply a view of history, which is deeply problematic because of everything, which is this colonial history and disrespecting, and also it's setting a border between inside and outside, and what is history and what's not history. And paleontology, the fossils, what is a fossil? It needs to be somehow buried at least several thousand years. Yeah, so maybe 5,000, 10,000 years, then it's a fossil. So that is then like long time ago. And people realized that history this is not too long ago, actually. In the time, let's start with this Duria Antiquior, the picture where we started during when Leopold von Buch gave his talks and about this picture, which showed this Jurassic world. He believed, I think, this is something like 10,000 years ago. People started at the turn of the 18th century only. Like it was really like that time. People started at the turn of the 18th century only. Like it was really like that time that people started to realize, okay, there is something really old that is really like, there were several worlds. And Cuvier was one of those. He spoke of this as revolutions, Earth revolutions, that there were lots of catastrophes before the biblical flood. And with each time, there was a different type of world. And then there was a catastrophe and then a new world. Because they saw only the rocks, and then they like in Paris and in France, where this happened, they saw, okay, there are tropical organisms, animals, elephants, things like that, and they don't live anymore in France. And then there's a break, and then you have a different stratum, a different rock bed, and it contains completely different. So they thought there must be a catastrophe. Of course, the sedimentary record is not continuous, so there are breaks, and there are long times where nothing happens, and there's erosion, and then there is a gap of the record. So it looks only like that there is something. Sometimes it happens faster, sometimes. Of course, now we know that there are times sometimes where evolution happens when there are catastrophes and things like that. But by that time, they started to think about that it is a long time, but they don't know. And as far as I know, so I'm not an expert in this, but I think the real methods to count this in millions of years, in terms of years, was only developed past Second World War. So only by that time we are able to use these geochemical methods, isotopes and so on, which use like the decay of lead and so on, and urine as a measure of time, and that can be used only in very special circumstances. Like I use methods which is called a stratigraphy. It's a science by itself, which uses fossils, which uses architecture of the strata, which uses also changes in sea level and things like that to correlate one bed in one area, let's say in Estonia, with another bed in Sweden. So to know, is this the same age? I don't measure the millions of years or the actual number of years. That's why I usually don't know these numbers so well. I usually know the fossils which are in there and the architecture of the rocks. So this is the way how we can build basically a very complex system, which is highly reliable and also has a high resolution. So when we go back 540 million years, I think there are places in the world where we have a resolution of within 1 million years. But when we go back into, let's say, Cretaceous, which is the time where the dinosaurs at the end went extinct, then we have a resolution of within 10,000 years or within thousands of years. And this is like sometimes, which is, for me, it gives me really a shiver when I see how fast things change in our world in terms of climate and ecosystems, because this is something which is so drastic. It happened really rarely in the history of life. It is so fast. It would be just a millimeter of stratum in many sedimentary beds, or is like a few millimeters only, so centimeters. So it would be really like, it is like a really an extreme event, like a meteor impact. So it's so fast and so drastic. And this is something which is for us, or still, even if the climate change accelerates at the moment and it's getting stronger and stronger, and it's still beyond the level of personal perception. Somehow it seems like, okay, yeah, we had other winters and when we were children, and the water is getting less and so on, it's warmer and so on, but it's still kind of difficult to grasp. But in terms of deep time, it's unbelievable fast.
But I feel like there is in general an issue with all the extremities. So even like talking about deep time, to me, it's like I cannot really imagine like, so what is 1 billion of years? It's very abstract. It's like I understand it on an intellectual level, but it's something so beyond experience of a person. That's one thing. And the second thing, if something happens very fast, as you say, like it's so extremely fast how the climate change is, it's like meteor just crashing. It's also hard to comprehend it because it's just too fast. And I think that human is not very good with these extremes when it's too fast and it's too slow. And my question would be, so what one can do to understand it on a deeper level, not only on like a theoretical perception of like, yeah, there is a climate change, scientists said that, or there was a deep time because some scientists said that. I think actually it's a part of a problem that it's so abstract that it's very hard to do anything because it's not part of the experience.
I'm confronted with this really like often because I go in the field and collect fossils, and I'm sometimes in places where there are lots of fossils, and it's like you walk on a sea bottom and you see all this, especially in Estonia, there are places like lots of corals and organisms which are completely, totally strange. And I think, what a strange world. And this, if you think about it, it's not just a fantasy world, it was Estonia just in that time. Yeah. And we all have probably places where we can go, which are a little bit more familiar to us. When you think about this place was a long time ago so different. And especially when I last year walked and had field work in Kilpisjärvi. And this is a time when animals barely appeared. So it was by reconstruction, what we know now, it is the sediments, they look a little bit like wadden seas. So shallow, sandy, flat, quiet beaches. And for me, I understand the sedimentology. So it looks really, and there are places where you can really walk on the surfaces of these sediments. And it looks like you are walk on the surface of a beach somewhere on Mars or something, because it's so weird and there are even places where there are our interpretation at the moment, these are hail drops. So there are imprints of there was a hail shower, and then these drops produce these little tiny craters on microbial mat surfaces, so on a muddy surface, and another bed was on top of it, and that is preserved now. So this is like crazy. So there is this tiny event of a second preserved over 500 million years, and this is totally incomprehensible actually. But it is for me now a sign that there is also a long presence, so that there is always something in this long time ago happened, which is still some kind of present, because it's still like this memory is, when we see it, it is still there because we see it and we can reconstruct it. So, and a couple of weeks ago, I read this very nice picture. It comes from Abi Warburg. He saw history as an impact of raindrops. So there's always something coming back from history. Like there are sometimes large impacts and small impacts. Like if you have a random events of things, totally random, which come back from the past and are still in that sense, in a way, kind of ghosts or present. And this forms like a continuum which goes really back into a time which is completely incomprehensible by us, but still impacts us. I try to understand this, at least sometimes, I'm getting older. I'm now in my 50s. So this is a very interesting fact when you're getting older, that you have a longer overview about history, and that this is also changing the perspective a lot on life, which is, I think, totally underrated, because it's so important that elder people have a different perspective on life than younger people, on past and on the length of life. But then I'm now in an age where I can see there are places where I was when I was a child, there was a tree which didn't even exist, and it's now a big tree. So the trees grow. It's something you at some point realize in your life, that they are not simply there, but they grow. There are places which I know where the oldest trees are 1,000 years old. That means in northern Germany, by that time, that was colonialized by the Germans. That was Slavic land and not Christian land. So this was like the time of colonization of this northern German area where I come from. And then going back to the Ice Age and so on. And then it ends at some point. There is no imagination anymore left. There is this long history, like the coal, which we dig out now. So if there would be no coal, we wouldn't have this capitalism like it is like now. And this long history has an impact on us. And of course, then what we do also will have a long history in the long future. So, but I think at the end, there is no way to overcome this. But I think it's very important to keep this history, this sense of that we are not a point in time, but that we are in a continuum, that we have a responsibility, and that we also are dependent on something which happened millions of years ago.
If this perspective of a deep time, that we are on the continuum, we are part of continuum, would be much more present, we would make different decisions in a way.
We know so much at the moment, and we don't do other. And I think it's because of other reasons. So we know all what's happening in the world, and no change. And I think this is like a question of how human societies are at the moment organized, and I don't know if there is a way out. When I was young, I always was very optimistic that there will be a revolution, everything will be better at some point and so on. But at the moment, it doesn't look like that. I mean, one thing we for sure know is that there will be no exponential growth forever. It is impossible. It's just against any physical law. So what's going on at the moment will end at some point.
What is the oldest fossil you ever seen?
Probably, I was in Namibia a couple of years ago. There are fossils of bacteria, of cyanobacteria, and cyanobacteria, when they cluster or are concentrated in shallow, slimy molds, they form cauliflower-like structures, buildings. They are called also like reefs. And these structures are fossilized. They can be like table size big, or even much bigger, like a room or a house. And they are called stromatolites. And they can be these are among the oldest like physical large scale traces of life, and which we could call fossils. And I think I saw one of these really 2 billion years old. Namibia is a place where there's many of those old, in South Africa and Australia also.
Can we say that bacteria are our ancestors?
Not the ones who live now, but because the bacteria who live today and the bacteria and us, we have the same ancestors. And they were bacteria.
So we are cousins with cyanobacteria, let's say.
Yeah, absolutely. Yeah. Every life is.
Everything is cousin to everything.
Yeah, and the further in time you go back, the fewer of those, and the closer you get to the ancestors of all the lives forms.
The past is written in stone, but that stone is in constant movement. And so are the stories humans tell each other about time before time, which keep changing our present and the future. If you liked this episode, please share it. If you would like to know more about the show, listen to this episode again, or find previous episodes, please go to fermentradio.com. You can subscribe to this podcast on Spotify, Apple Podcasts, and more. We would love to know what you thought of this conversation, hear your human microbial stories, and your suggestions for the future episodes. We are always looking forward to hearing from you at hello@fermentradio.com. You can also leave us an audio message by connecting to us on our Instagram. Ferment Radio is brought to you by Super Eclectic and is supported by Microbial Lives, Practices of New Human Microbial Cultures, a project at the center of the social study of microbes. I am very grateful for this support and most of all with all our amazing Ferment Radio listeners. Keep fermenting and stay tuned for the next episode of Ferment Radio.